Hello, my dear students. This is Sheetal Srirangdange. I am working as assistant professor under the Department of Pharmaceutical Analysis. Today we are in St. Paul's College of Pharmacy. Today we are going to discuss about the basics of organic chemistry. So these are the very basic points for the students who don't have the basics of organic chemistry. So what exactly the organic chemistry it means? First we'll see the introduction part. Chemistry deals with composition, structure, properties, interaction of matter, and is much of use for the human beings in our day-to-day life. So our day starts with the products which contains the carbon containing compounds as well chemicals which we are using for the day-to-day needs, like we are using utilities goods like acids, alkalis, dyes, polymers, metals. So these industries contribute very big role in economy of nation and generate the employment. Then science of organic chemistry is about 200 years old. Around the year 1780s, chemists begin to distinguish between organic compounds obtained from plants, animals, and inorganic compounds prepared from the mineral sources like calcium carbonate, NaCl. These are inorganic compounds. Then this chemistry is divided in many types like astronomical chemistry, then physical chemistry, synthetic chemistry, analytical chemistry, and organic chemistry, inorganic chemistry, biochemistry. So when it deals with a carbon containing compound, then only we will call it as a organic chemistry. But here one exception is there, carbon dioxide and carbon monoxide. What will be the definition of chemistry? It is the branch of science which deals with composition and structure of elements and compound molecules, how the energy that is released or absorbed. Then organic compounds are the compounds which contains the carbons like methane, ethane, but carbon dioxide and carbon monoxide are the exceptions. So moving to the next slide, this is the basic structure of carbon, and in figure I have shown here ball and stick model of methane. See, methane will represent with the CH4. Carbon is having the 4 valency. If you see the periodic table in your book or in our labs also, atomic number of carbon atom is 6 and atomic weight 12, and electronic configuration will be 1s2 2s2 2p2. So either carbon will give its 4 electrons, or R it will accept 4 electrons to complete its octet. Because of that, carbon valency is 4. In wedge and dash representation of methane, I have shown this diagram, which front side, if we see the 3D structure, then we can say this structure. Some bonds are shown with a distinct or dark line and some are with a light line. So if the hydrogen is or the bond which is present on the side of observer or the viewer, we will show with a dark bond, and which is away or back side of the carbon atom, the bond is there, hydrogen is attached with the carbon atom, but still it is not visible for the viewer. That time we will show with a dotted or dotted here with a light color I have shown, but we'll show with a just dash dash showing with the dotted lines like. So here the bonds in the plane of paper, first upside hydrogen and here left side hydrogen we have shown. Dashed wedge means bond away from the observer, and solid wedge or dark line, it is for the bond towards the observer. Then we will see now important part of the syllabus, which is as per the PCA rule for the B Pharmacy first year second sem. So they have mentioned classification of organic compounds in your syllabus. The existing large number of organic compounds and their ever increasing numbers made it necessary to classify them on the basis of their structures. See, many compounds are there and day by day new drug derivatives are also prepared. So because of that, to classify them, it is very much needful. On the basis of their structure, if you classify, it is easy to learn their physical chemical properties when you are using in preparations, synthesis, or for reaction mechanism studies. So this is the main slide in which I am going to explain you about the classification of organic compounds. So mainly the compounds are classified in two types. One is acyclic. First, majorly it is divided in two types: acyclic or open chain compounds, and cyclic or closed chain or ring compounds. So acyclic or open chain compounds are the compounds which have just straight open chains. Then these acyclic compounds, those are not in the form of cycle. That's what it is called as acyclic compounds. Those are divided into two types: saturated hydrocarbons and unsaturated hydrocarbons. Means compounds which are made up of carbon and hydrogen, but the carbons are and hydrogens are attached with sigma bonds or single bonds, or also you can say it as a there is absence of carbon carbon double bond or carbon carbon triple bond also, or unsaturation, that is carbon double bond O also. So those compounds are saturated hydrocarbons. The best example is methane, ethane, or propane. Alkanes are saturated hydrocarbons. Then second class is unsaturated compounds, organic compounds with unsaturation. Like unsaturation means there is presence of carbon carbon double bond or triple bond. So these bonds are not only present between carbon, sometimes double bonds are present between carbon and sulfur, carbon and oxygen, and isonitriles like N triple bond C, or cyanides or nitriles C triple bond N, and alkynes C triple bond C. So example is again ethene. Alkene is the functional group family. CH2 double bond CH2 is the example for unsaturated compounds. Then coming to the next class, cyclic or closed chain, also we can say ring compounds. These are also again divides into two types. One is alicyclic compounds and aromatic compounds. Kindly do not get confused with acyclic and alicyclic. Acyclic means there is no any kind of cycle, only open chain carbon skeleton will present, but in alicyclic we'll be having the closed chains. So alicyclic compounds divides into again two types: homocyclic compounds and heterocyclic compounds. Homocyclic are also known as carbocyclic compounds, in which example will be cyclopropane. So examples I have made in the next slide I will show you. Then heterocyclic compounds are non-aromatic, but still they are present in cycle, like tetrahydrofuran. And aromatic compounds means which follows the Huckel's rule, which is 4n plus 2 pi electrons. N is equal to number of pi electrons, which satisfy the rule. Those compounds are aromatic compounds. Or another one will be if there is a presence of benzene ring or aromatic ring, we will call it as a aromatic compound. Aroma means characteristic odor will be there for the compounds. Specific odor, like if you put the agarbatti or udi, by smelling it we are able to say, because this organic aromatic compounds have their characteristic aroma or odor. So in this also we have three types. Benzenoid compounds means the compounds which contain the benzene ring. Then non-benzenoid compounds are tropane, which not have benzene ring but still it is aromatic in nature. And third is heterocyclic aromatic compounds like furan. Then see, acyclic open chain compounds, example ethane, acetaldehyde, and CH3COH, which is acetic acid. In this, whether it is saturated or unsaturated, both will comes under the acyclic or open chain carbon skeleton or chain, we can say. And definition also I have mentioned here. Then this is the definition of saturated compound: absence of saturation or any double bond or triple bond. Those are made up of carbon carbon single bonds. Ethane, example unsaturated, presence of unsaturation. So these are the definitions and with example. Then alicyclic compounds examples are, those are also known as aliphatic cyclic compounds. First one, only cyclopropane is aliphatic cyclic compound, uh, and remaining saturated and unsaturated, we can say. Here cyclopropane is having 3 carbon atoms, so you can represent with one triangle also. And this second one is cyclohexene, there is one unsaturation, so you can say unsaturated homocyclic compound. And third one is cyclohexane, just made up of 6 carbon atoms, C6H12. So aliphatic compounds means both will come saturated as well unsaturated. So sometimes atoms other than carbon are also present in the ring. Then we will call it as a heterocyclic. Means carbon atom will get substituted either with oxygen, nitrogen or sulfur. Most probably these three atoms are found in cycle of carbon atom as a heteroatom. So this is the example of this heterocyclic compound, which carbon of 5 membered ring in which carbon replaced by oxygen. Example is tetrahydrofuran. Either you can mention just ring with oxygen, and here with the hydrogens also we can mention. Then aromatic compounds, I have mentioned here examples. Benzene, aromatic ring with NH2. This is aromatic primary amine, and when two benzene rings are condensed together, then we call it as a naphthalene. The non-benzenide compound I told you, which is not having benzene ring, but it follows the Haeckel's rule and it is aromatic in nature, that is tropane, but it is 7-membered ring of carbon atom. Heterocyclic aromatic compounds, furan with oxygen, thiophene with sulfur, 5-membered rings, both are. Then third one is 6-membered ring, pyridine. So this is the basic classification of organic compounds. So organic compounds can be classified on the basis of functional group chart and families of homologous series. And definition of functional group, which on the basis of which we are going to classify the organic compounds. That is, the functional group means the most reactive part of the reagent, which is active part. And if it is a RNH2, example aromatic aliphatic amine, then amine is the functional group and R is the hydrocarbon moiety or part of that functional group. Then examples I have mentioned here few with family name of functional group and example. You can see alkane have example ethane, alkenes ethene, alkynes ethine, and alcohol ethanol, and aldehyde ethanol. So these are the different functional groups which will get categorized on the basis of their kind of functional group contains double bonds, triple bonds, or containing halogens, containing oxygen, containing nitrogen. So in next presentation we will see functional group chart, and here I stop my recording. Kindly subscribe my channel, and if any queries there, kindly post in the comment section. Thank you.